Let's look at the image that you saw on the website, IMAIOS. Look at the picture of the patient lying in the bore of the magnet. He is face up, his head went in first. So right now in your chair, what I want you to do, you're looking at the TV screen or the computer monitor, I want you to spread your left and right arms out. Spread them all the way out like you're going to come up to your best friend and give them a hug. If you were lying in the bore of the magnet, your left arm and your right arm are showing you where your X gradient goes. Your X gradient is going to adjust the main magnetic field, the B0 value, from one side, the left side, to one side, the right side, so that the magnet is actually just a little bit less powerful on one side than the other. Looking at your picture, if the patient on the bore of the magnet was to do exactly what you are doing now, his left arm would be the positive side of the magnet, of the X gradient. His right arm would be the negative side of the X gradient. The left arm of the patient, the magnetic field there on the left side of his body is just a little bit more powerful than on his right side, where his right arm is. It's just a little bit weaker. The reason we want to adjust the main magnetic field is so that we can actually quantifiably calculate the exact spin of the protons from one side of the magnet to the other. When we do that on a mathematical equation, what we'll see is we can calculate to the tissue, to the proton, where it is located in the body. On that axis, that's important to know. The X gradient separates the spin of each proton from your left arm to your right arm. That is going to help you create sagittal slices, because think about it, if every proton along that axis from your left arm to your right arm is going to be spinning at a slightly different precession within the bore of the magnet. So I can separate the spins of the protons on my left fingertips from those on my right fingertips. Left to right are sagittal slices. So in this case, if the X gradient is used as your slice selection gradient, you are creating sagittal slices. X gradient, sagittal slices. So before we go too far into phase and frequency encoding, let's go through the other two gradients, the Y gradient and the Z gradient. We've already covered that the X gradient, if you're lying in the bore of the magnet and you go in head first and you stretch your arms left to right, that is the X gradient. So between left hand and right hand in a bear hug, you're changing the precessional frequency of the protons along that path. So now let's find out where the Y gradient is. Okay, so let's take that same image from IMOS. If you were the patient and you were put into the bore of the magnet head first, face up. The Y gradients are a set of gradients that are both anterior and posterior to the patient. There are two sets, one at each end of the magnet. So if we did the same analogy as we did with the X, so take your arms, instead of a bear hug, stretching them out left to right, stretch them out anterior and posterior to you. Your left arm way in the front and your right arm way behind you. The main magnetic field is going to be adjusted anterior to posterior by the Y gradient. So the fingers in the front of you from the fingers in the back of you will have different precessional frequencies. Again, if everything changes along this pathway, what you'll have will be coronal slices, because the precessional frequency of the protons at the very front, or the anterior aspect of the patient, will precess differently than the protons in the posterior aspect. So we've talked about the X gradient being the bear hug gradient left to right, making sagittal slices. We've talked about the Y gradient being the anterior-posterior gradient that makes coronal slices. Now let's talk about the Z gradient. And I can imagine you being as astute as you are, you can figure out that the Z gradient is going to change the magnetic field from the head to the foot of the patient, making axial slices. Let me show you how. Again, going back to our website, IMUS, you see two green, in this illustration, circles. One at the very entrance of the magnet, one at the other end of the magnet. These two rings work together to change the main magnetic field. Remember, that's the B0 field, just a little bit from one entrance to the other. Look at your picture. See how the patient's going in head first. That means at the far end to your left, the main magnetic field is just a little bit stronger than where he first comes in on your right. The purpose of changing this magnetic field is so that when the patient's head is in the middle of the magnet, as it is in this illustration, the protons that are spinning and precessing at the very top, the most superior aspect of his head, are precessing just a little bit faster than those at the base of the head. And that's going to allow the MRI technician to separate axial slices through the body. Again, the whole purpose of these gradients is to be able to specifically the proton from the left side of the body to the right, from the anterior part of the body to the posterior, from the superior part of the body to the inferior. All three gradients, X, Y, and Z, if they're used as a slice select gradient, then what they're going to do is be able to say the X gradient is going to be used for your sagittal, your Y gradient for your coronal, and your Z gradient for your axial images.